In video 7, we now finally head into the small intestine. So I've said this several times, but I'm going to say it again. The small intestine is where most chemical digestion and absorption take place. It is very long. Small intestine, remember, it's called small because of its diameter. It's actually much longer than the large intestine / colon. So it's designed to increase surface area. So it's 8 to 13 feet long in a living human being, 20 feet long in a cadaver. The reason it's longer is because it relaxes, that smooth muscle relaxes after you die, and it will be longer. So it is designed to increase surface area, more chemical digestion, more absorption of nutrients into the bloodstream. So this is where most digestion and absorption occur. I said in the last video, you can live without a stomach, you can live without a large intestine, you cannot live without the majority of your small intestine, because it is the way that you get nutrients, break them down, and get them into your bloodstream. So from an anatomy standpoint, the inner lining have villi, so you don't have a smooth epithelial, you've got these villi. Okay, this increases surface area, more surface area for more enzymes to break down more fuel nutrients that you need, and then more surface area, most importantly, more surface area is more important for more diffusion of these fuel nutrients into the bloodstream. Not only do the villi exist, but there are villi on the villi called microvilli. So you've got these larger villi, and then you've got these microvilli, again, to further increase surface area for more absorption of nutrients. Now, we mentioned this in the last video. There are two accessory organs, the liver and the pancreas, that are going to be critical to allow the small intestine to do its thing. So we're going to talk about each of those as they apply to digestion. We're going to start with the liver. The liver is the largest internal organ. You can actually do a live donation of the liver. You can donate a lobe of your liver to someone, and it will actually increase in size in your body to the size that you need it. So that's kind of cool. So a lot of times if babies are born with livers that do not function, their mother or father can actually donate a lobe to them. The problem with the liver being so large is that you've got a lot more than you need, but if it becomes diseased, you might not know about it until it's too late. So one of the symptoms you may get if your liver is not functioning is you may get yellowing of the eyes or jaundice. That means your liver is not able to break down red blood cells, which we'll talk about later, which means it's building up in your system, and then it finally shows itself in your skin or in the whites of your eyes. The problem is by the time your liver gets to that point, it's usually kind of hopeless. There's not much they can do to help you. Also, if cancer metastasizes to the liver, that's pretty bad because it has such a large blood supply and means it's getting so much blood, and that means the cancer, usually when it gets to your liver, there's not much they can do to help you because it's going to move very quickly or metastasize around your body. So the liver, largest gland, brain of the digestive system. You have the hepatic portal vein, which we have not talked about yet. We will, but the hepatic portal vein is a vein that comes from the small intestine. And so all the nutrients that are absorbed by your small intestine head to the hepatic portal vein and head to the liver. And the liver, what I meant by brain of digestive system, it's going to decide where these nutrients are going to go. Do you need them? Do we need to store them? What's the body need to do with them, depending on the state of your body at the time that they get to the liver. Hepatocytes are the cells of the liver. They have leaky capillaries around the hepatocytes called liver sinusoids. This allows a lot of meeting of the blood with the cells. And then we also have your immune system within the liver called Kupffer cells. So what do hepatocytes do? They produce bile, which emulsifies fat. So we've talked about this before. This is an example of mechanical digestion. So the bile is produced by the liver, stored in the gallbladder. When you have the small intestine, when the stomach kind of squirts that little bit that we talked about of chyme into the small intestine, fat is present, then the gallbladder will secrete bile into the small intestine, into the small intestine, that will emulsify fat. It is a mechanical digestion. It takes a larger fat globule and makes it into smaller globules. What this does is this increases the surface area. There's more surface area for the enzymes to then break down the fat, which we'll talk about. If you do not have a gallbladder, and then what will happen is the liver can directly secrete the bile into the small intestine without being stored in the gallbladder. The hepatocytes, the liver also is detoxification. It breaks down toxic substances, ammonia into urea. The taking in of medications and drugs, legal and illegal, is broken down by the liver, and then that's secreted into the urine. It stores fat-soluble vitamins. So some vitamins you have to be careful of because they can be toxic, because they can be stored. That's vitamins A, D, E, and K. You have to be careful with those. You can't take too much in of them. And then what will process incoming nutrients. So when the nutrients from the small intestine come in from the hepatic portal vein, it will again decide where it's going to go. Will it store them? Will it send it to the cells for the cells to use it as energy? Now, what happens is, like I said, when everything is absorbed from the small intestine, the first place it goes is to the liver. If you watch medication commercials, they will talk a lot about knowing your liver function and how it's functioning and how it's working. Medications, when they go from the liver, they go to the liver from the small intestine. What will happen is, so you take a amount of medication, it goes in your small intestine, you absorb it, depending on some you may absorb through the stomach, but you absorb it. That medication then heads to your liver. During that first trip to your liver, that medication, the process of breaking it down, which is what one of the things the liver does, will start to take place that first time through the liver. And then it will send it out into the bloodstream. So they need to know liver function, because if your liver is not functioning as well as it should, you might not break down as much of the drug the first time through. You take it, small intestine, liver. If it doesn't break down as much, the dosage you may get may actually be higher than it should be. So that's one reason they have to know liver function, and your liver is going to determine how much that medication is going to actually end up into your bloodstream. Now, being on medications constantly can also start to wear away at your liver because it's spending all that time breaking it down. So, medication goes from small intestine to your liver, into your bloodstream, and then that bloodstream will come back to the liver, and then it will continue to be broken down over time as it comes and goes from the liver. So again, they have to determine how well your liver is working to determine what your dosage should be. Gallstones are when cholesterol precipitates, and they get these little stones, gallstones, and what can happen is they can get stuck in your cystic duct. So especially after a high-fat meal, not always, after a high-fat meal, what will happen is there's fat in your meal, there's fat in your small intestine, it wants to secrete the bile, the stones will get stuck in that cystic duct. That can cause a lot of pain. It's not always with high-fat meals. With some people, it just hurts anytime they eat. So again, you can live without a gallbladder. They can take that out, and you'll just secrete bile directly from the liver into the small intestine. The pancreas is the other accessory organ. The pancreas is posterior behind the stomach. Remember that from lab. It works as an endocrine and an exocrine gland. You're probably most familiar with it in terms of insulin. We've probably already talked about that when we talked about homeostasis. But it was the primary organ responsible for the digestion, providing the enzymes to the small intestine to allow for digestion of the fuel nutrients. So, after you eat, we mentioned this before, it goes into your small intestine. That presence of that chyme from the stomach in the small intestine will cause the pancreas to secrete enzymes into the small intestine and will do the digesting, the majority of the digesting of the fuel nutrients. So that is the exocrine part of the pancreas. So it is critical for that. It is critical for digestion. If your pancreas is not functioning, if you've ever known anyone who's had pancreatitis, it's very painful from what I've heard, and they can't really eat because every time you eat, what will happen is your pancreas will get that signal to secrete those enzymes, and that can be very painful when the pancreas is inflamed. Pancreatic cancer, you may have heard of. Pancreatic cancer has a very high death rate. a low survival rate, a 5-year survival rate. The problem is there's not a ton of symptoms, and a lot of times by the time they catch it, it's too late. You have to catch it very early, but like I said, there's not many symptoms, so it is difficult to catch it early. The other thing, this is still the same, enzymes will proceed to do that, sorry. Examples of these enzymes include trypsin, amylase, lipase. Again, IN is going to be an enzyme that is going to break down proteins, ACEs, lipase, lipids, amylase, carbs. These are just a few examples of the enzymes that the pancreas contributes to the small intestine. Okay. All right, we'll talk about insulin and glucagon and the role that the pancreas plays in maintaining blood sugar. We'll talk about that later. All right, so small intestine, chemical digestion of the three fuel nutrients occurs here. Okay. It's so long that the nutrients can be absorbed into the blood. Most absorption occurs in the small intestine. The villi and microvilli are going to increase the surface area for more absorption. All right, we're going to stop here, and in the next video we'll talk specifically about how each of the 3 fuel nutrients is absorbed and digested in the small intestine. So again, make sure you can match your objectives. You can answer your objectives based on this video.